Hi friends, let's continue our discussion on solving this 0-1 knapsack problem using branch and bound. As we know, branch and bound method are used for minimizing, but we have a problem of knapsack, that is to maximize. So instead of maximizing, we can use the branch and bound and try to minimize. So instead of maximizing profit, we can minimize the loss. So the profit can be converted into loss with a negative sign. So that's a simple logic of converting maximization problem into minimization problem. So in this, let us use the last in first out logic and see how the process continues. So we start with our first node where our knapsack is empty. That means we can add the first one with a negative sign. So that takes a unit of 4, capacity is 18. So second one can also be added. So 4 plus 6 makes 18. Then can we add third one, 18. So 10 plus 3, that makes 13. Yes, third one can also be added. So now we have total weight is 13 in the sack. We need 8 more, but 8 more are not possible. Therefore, what is possible is 5 more. So we can take up 5 more. So 32 by 8 is 4, 20, 40, 50. So that makes minus 65. And u is without this fraction, that is minus 10, minus 20, that is minus 30. So that makes minus 45. Next step is, so talking about if first item is used or first item is not used. So with this, second and third nodes are created. So if the first item is used, it's going to tell us the same thing, minus 65, minus 45, doesn't make change. So anytime the left child will borrow the entries of the parent, only the right child will change its values. So what says about the right child is, it says the first one is not used, then we are left with only second, third and fourth. So we can use second one, 6 units. So still there is space. So we can add third one also. So that makes totally 9. Another 9 units are left, but we have next item with only 8 units. Therefore, this total can be added without any fraction. So that makes 35, 32. So that makes minus 67. And because it is totally used, so that's minus 67 only. So last in first out, the last item added is 3. So to the 3 we get into and we create 4 and 5. So as we discussed, so this is x2 equal to 1, x3, x2 equal to 0. So the left child will borrow as it is. So that makes minus 67, minus 67 as it is, nothing to worry. Only the right child will change. So x1 not used, x2 not used, then we are left with only x3, x4. So the total size is 11. That means nothing is fraction. So that makes it is minus 47. And this u is also minus 47. So 3 is done. Then now at this level 2 is still unaddressed. So 6 and 7 will come. So this is for x2 equal to 1, x2 equal to 0. As we said, this will continue as it is. So you want to verify that. It says x1 is there. Yes, x1 is there. You say x2 is there. Yes, x2 is there. Then x3 can be used. So that makes x3 can be used, but x4 cannot be used totally. Therefore, 32 by 8 into 5. So that makes the same logic. So that gets us 2 minus 65 as the cost, minus 45 as the upper bound. Okay. Then this side, 1 is used, 2 is not used. That means 10, 15. So 4 plus 3 is 7, 7 plus 8 is 15. So 15 is less than 18, so no fraction is required. So 10 minus 15 and minus 32. So that's minus 7 and 3, 4, 5. So that makes minus 57, both cases, because it is only first and second is not used. 1, 3 and 4. So 4 plus 3 is 7, 7 plus 8 is 15. So it is less than that. So we don't need any fraction. Done. So who is next? The last item. Last one is 7. So in this row, 4, 5, 6, 7. 7 is the latest entry. So next one is solving this. So that makes 8 and 9. So definitely this is minus 57. This is minus 57. So this is x3 equal to 1, x3 equal to 0. So if x3 is not used, x1 and x4 only are used, then it makes minus 42. Minus 42. Done. Then who is next? 6. So from 6, we generate 10 and 11. Okay. Then what is its thing? So this is minus 65. This is minus 45. So this is x3 equal to 0 or 1. x3 equal to 0. So if 1, 2 and 4 are used, 1, 2, 4 are used, yeah, it is 30 plus 32. So that makes minus 62. This is minus 62, and that continues. Now at this point, I would like to make some interesting point. So in all, if you just continue looking at this level, then we have minus 45, minus 45, minus 67, then minus 45, minus 57, minus 67, minus 47. Okay. Then we have minus 45, minus 62, minus 57, minus 42, and so on. So when we reached minus 67, then you look at it, this is talking of minus 45. And if I continue, then I may get minus 45, and then, or I can get to minus 62. If I continue this, I will get minus 57, I can get minus 42. Same way, if I continue here, I may get some smaller, bigger values than minus 62. So what is it say is, I can prune it here, I can prune it here, I can prune it here. So these things are no more required to continue. So we can directly declare this and then continue from here. What is it? x3 equal to 1, x3 equal to 0. So this gets you to minus 67, and then you say x4 equal to 0, 1, x4 equal to 0. So that gets us to minus 67, and that way we can tell minus 67 is the answer, which says that x1 is equal to 0, x2 equal to 1, x3 equal to 1, x4 equal to 1, and maximum profit is opposite of minus 67 is plus 67. So that way we can do it. Other way, if you just look for a least cost method, then this is minus 45, this is minus 67, therefore this is least cost. So we continue with this, then we get two things. So we get minus 67, minus 47. So this is least. So we continue with this, and then when you look at it, then we get minus 67. Therefore, we continue with this, and finally we get another minus 67. So we continue with this, and the flow says x1 is 0, x2 is 1, x3 is 1, x4 is 1. So with least cost, you don't have to worry about all these things. We can directly get to the thing. So if you want, we can just take up one final look at that. So that is 1, that is minus 65 minus 45. Then we get to 2 and 3. This is minus 65 minus 45, and 3 was minus 67 minus 67. Then we get this 4, 5, and this says minus 67 minus 67. So this is x1 equal to 1, x1 equal to 0, x2 equal to 1, x2 equal to 0. So if you don't include x2, then we get 47, 47. So minus 47, minus 47. So this is the winner, 45, 67, 47. So this is the smallest. Therefore, extend this. So x3 equal to 1, x3 equal to 0. So we get the sixth node. This is minus 67, minus 67, because it is the left child. We don't have to calculate. But as seventh child, so first is not there, second is there, third is not there. So second and fourth only are there. If you look at second, fourth only, so that makes total of 14, which is less than this. So totally it will be available, that is 52. So this is minus 52, this is minus 52. So this is 67, this is 52. Therefore, this is the winner. So we extend this, x4 equal to 1 and x4 equal to 0. So with x4 equal to 1, we get 8th node, x4 equal to 0, we get 9th node. With 1, this is minus 67, this is minus 67. So first is not there, second is there, third is there, fourth is not there, only second and third are there. Then it is minus 35, minus 35. So that's a winner. So the path to the winner is this, and this, which says x1 is 0, x2 is 1, x3 is 1, x4 is 1. Therefore, the X matrix is x1 is 0, x2 is 1, x3 is 1, x4 is 1. And the profit, if you look at it, so for x1 there is no profit, x2 it is 20, then 15, then 32. So total profit will be 67. So that's the simplest way of solving. So we say that least count method is the efficient method to solve the problem. So that's it for now. So keep watching for many more videos to come. Thank you.